This is Pillar 4, Arterial Concepts, Understand Token. First, I'm going to be talking about the Windkessel model of the arterial system. I'm going to go over the mechanical and then the electrical representations for this. So on the left is my mechanical representation. So this is a spring, which is supposed to resemble the like time-varying elastance. So I'm going to denote that as E. This is, of course, the left ventricle. This is the mitral valve. This is the aortic valve. This represents, the faucet represents resistance. So blood goes in through the mitral valve into the left ventricle, and then it goes through the aortic valve and into the aorta at the arterial system. And it can do two things. It can either expand the vessel, or it can go out through resistance and flow out. So we have two options. Expanding we're going to call radial flow. And then we're going to call this flowing out resistance at axial flow. And then if we go over to the electrical diagram, we have the same thing. So mitral, this is left ventricle, or this node represents left ventricle pressure. This is the aortic valve. This represents aortic pressure. This arrow represents aortic flow. This capacitor represents 1 over the elastance, time-varying elastance. This is the arterial elastance, and this is the arterial resistance. The way a Windkessel works is that a flow is ejected from the heart, and it can either flow into a capacitor or down the resistance. So down the resistance or capacitance would be the expanding. When the heart stops ejecting, the pressure in the arterial system is maintained because there is a volume in the capacitor. As some of the volume drains from the capacitor through the resistance, the pressure drops in the arterial system until another volume is ejected from the heart. Another way to represent the arterial system is through this diagram with the use of an inductor. Inductance represents fluid inertance. So it's kind of the same idea. Aortic pressure, it's over here, aortic flow, and then obviously a capacitor and a resistor. From this model at 0 frequency, the impedance will be R. At lower frequencies, the inductor will not apply, but the capacitance will dominate. And as frequency increases, the inductor will become dominant and the phase will become positive. That's all. Thank you.